Hello, so today we'll see how to develop Kalima smart contract node. Smart contract node is a Kalima Java node which able to run JavaScript or Python smart contracts. So first you can go to kalima.io, click on testnet, enter your email, and then you will receive an email with some information, an email like this, with some information like serial IDs. Serial IDs are used to authorize your nodes on the testnet. Here you can see also some addresses. So we automatically create 5 addresses for your tests. So for 4 addresses on which you are authorized on read and write, so you can read data on these addresses and put new transaction. And another address which starts with Kalima contract, and this address is on read only, and this address is used to store some information about your contracts. You can also find an address to our private Git server, and the inscription will automatically create for you an account on this server. And you have a repository. In this repository, if you create a contract directory and you push some contracts, JS or Python contracts, this contract will be deployed automatically to the testnet blockchain. And from kalima.io, if you click on developers, build developers, no, sorry, then on GitHub, we'll find our public repository, and you can access to our libraries, for example. So for our tutorial today, you just need to download in etc-lib the Kalima sc.jar. Sc is for smart contract. So you just download it, and we will use in our project today. So now from Eclipse, I will start a new Java project. I will name it smart contract node. Okay. Then I will create folders. First, I will create Eclipse folders to put my the Kalima library. So I will copy Kalima sc.jar here, and I can add it to my build path with right click, build path, add to build path. And then I will also create a folder CLG to put the config file of my Java node, because all Kalima Java nodes need a configuration file to set, for example, the private chain on which we want to connect to. I will create a package, an example of Kalima.to. And for our project, we need 3 classes. So I will create first a class named clients. This is my main class. I create a class, I will name it, for example, Kalima client callback. And this class will implement client callback from Kalima API. Okay. And the third one is, for example, cache callback. And in this class, need to implement memcache callback from Kalima. Okay. So in the first one, in the client class, I will set some variables to initialize my node, initialize and run my node. And Kalima client callback, in this class, I will initialize the contract manager. So it's the part of Kalima API that manage smart contracts. And in cache callback, I will set rules to run smart contracts. Then I need a reference to Kalima client callback. Okay, so I will create a constructor for my class, and I will run this node with one argument. This argument will be the path to my configuration file. So my constructor will take just one parameter, the program arguments, in fact. So in my name, I can call my constructor with args. And here I will initialize my node. So to create a node, I just need to create a clone preference. Clone preference is an object that will load the configuration file. So you just need to pass it the path of this configuration file, so the first argument of my program. I can initialize my logger. Clone preference automatically create a logger, so I can get logger. Then I need to create my clone, and the clone object just need a clone preference object. Okay. And then I need to instantiate my client callback, but I don't have a constructor yet, so I will do it later. Instantiate. Okay, and then I need to connect my clone to the blockchain with the connect function. And because I have a client callback, I need to pass it to the connect function. Then for Kalima client callback, no, before, sorry, in my client, I have some members, but I will create getters to access these variables from my other classes. So select all getters, and I will create again also a function get contract slash. Return a string, and in fact, it will also return my contract address. So in the mail, when you put your email in the description form, you receive an email with an address, this one, and you need this address here. Okay, so then for my Kalima client callback, I need a reference to my main class, clients. I need also maybe a logger for debug. And I need a contract manager. Then I create my the constructor of this class. It will take just one parameter, the instance of my main case. And here I can set my client and the logger. I can get the logger from my client. Okay. So let's look at the client callback interface functions. In fact, when you run a Kalima node, it will synchronize with the blockchain so that it receives all the data from the addresses on which it is authorized. So there are two interesting functions here, on cache synchronized and on new cache. In fact, on cache synchronized will be called by the IP Kalima once for each address on which you are authorized, and after the synchronization. So when you run your Kalima node, you will synchronize all data for each address. So in case of testnet, for all these addresses. And when you receive all data for one specific address, this callback will be called with the corresponding address. And on new cache is called before at the start of the synchronization, so before you receive the data for this address. So here you can put some code before the synchronization of an address, and here after the synchronization ends. So in our case, we will use this function to initialize our contract manager. So first I will create a function to initialize my contract manager. Mix contract manager. So new contract manager, this one is 3 parameters. The first one is the logger. The second one is a path where the contracts will be downloaded. You can put whatever you want, but a good practice is to use the logger path with logger base path. And the third parameter is a callback, contract callback, so new contract callback. Okay. And here we need to get contract information, because this callback will be called when a new contract is detected by your node. And in this function, you need to return information about this contract, and information about your contracts are stored in this address. So here I can name this parameter key. So here you need to get the KMG corresponding to the contracts. So from the clone with the get function, the first parameter is the address. So here is the contract cache address, and the second parameter is the key of the message. So it's the key that it's placed in the callback. Then if for a reason this message doesn't exist, you can just return null, and then here we can return information about the contract. So contract information get props, that get props again. Okay. So, but when your node will be started, he will receive all information about your current contract. So here we need to loop to all contract information and download corresponding contracts. So to do this, we need to set a for loop like this from the clone get memcache. So for the cache, get contract cache. You need to use the kvmap objects and loop through values. You can convert kmessage into a kmeg with kmeg.setMessage function, and then you can call contract manager dot download contract, and again get props dot get props. Okay, so this function will initialize my contract manager, and so I will call it from here. But here I will also create an instance of cache callback, because cache callback have, for example, put data and remove data functions, and this function will be called each time you received a new transaction about a specific address. So we need an instance of cache callback for each address. So here I will create an instance of cache callback, but I don't have a constructor yet, so I will do this later. And now, because I have a constructor here, I can create the instance of my Kadima client callback here. Callback that equals new Kadima client callback, and the parameter is this. Okay. So then, for our third class, cache callback, we need a string that represents the address of this instance. Again, if you want a logger to add the bugs, and an instance of my main class to get the clone, for example. I will create the constructor now. In my constructor, I need the address and the reference to the client. So here I can set the address and the clients and the logger from the client. Okay. And so the function get address need return address. And so the function put data will be called when you new data comes to your memcache. So if I create a new transaction the address LDR1, for example, with a string as a body, put data will be called with in parameters the message, the new message. But if I create a new transaction with an empty body, it corresponds to like a delete in the memcache. So remove data will be called with the old message and the new message as parameter. Here we need use put data to run there are two cases. If we receive a new data in this address, in fact, we need to download the corresponding contract. And if we receive data in other addresses, we want, for example, run a JavaScript contract, the corresponding JavaScript contract, for example. But you can run the contract you want with your own rules. Here is just this is just an example. So first, I can convert the key message in KMG with again function set message, and then I will set a if condition about the address of the message. So if the address equals the client's get contract cache, so my contract smart contracts address, I will download the corresponding contracts. So from the contract manager, my contract manager is in the client callback. Sorry. Here in client callback, I need a new getter for the contract manager. Okay, so yes, contract manager. Let's download contracts, and again, img get props dot get props. Okay, and else, so if I receive a new message in another address, I will run the corresponding smart contract. So in this example, if I will receive a new transaction, a new message in this address, I will run a JavaScript contract named address1.js. And if I received a message in this address, I will run address2.js script. So I will first split this address in function of the slash to get only these parts. Okay. So it's address equal get address split on slash. And so my contract name that I want to run is split address, the last split address, so split address length on this one plus .js or .py if I want to run a Python smart contract. And then I will just call the run function of contract manager to run my smart contract. So I call back get contract manager run function. The first parameter is the name of the smart contract. So here is contract name. The second is the name of the function inside my smart contract I want to run. For example, for our example, the function is always main. And then you can pass all variables you want to your smart contract. So I can stop here, for example, but for our example, we want to pass the received message, the clone, because with the clone, I can then send new transaction or read some data from the blockchain directly inside my smart contract. And then I can pass also the logger to add a debug from my smart contract. And the last thing, in Kalima client callback, I will set the new instance of cache callback for all address. I can here get clone dot add memcache callback, new cache callback. Okay. So then, as I said before, all Kalima Java nodes need a configuration file to run. So here in kalima.io, you can access to our documentation. You can go in API Java, API Java, and here you have an example of configuration file. Okay, so I will copy it. Here I can create a new file. I need, for example, not.config. Okay. And I will pass this. So here is the file path. The file path is a location in your computer where the logs, for example, and logs and other files will be stored. So, for example, I will say it's tutorials / smart contract node. Okay. Here is the serial ID. So when you use the inscription form, you received an email with some serial ID. So I will copy it and paste here. So the serial ID is used when you launch your node for the first time, and this serial ID is used to authorize your node. And the private chain for the testnet is org.kalima.tuto. Okay, so then, as I said before, we need to pass the path of the configuration file to our program. So I will create a new configuration here. So my main place is client. Okay, and in argument I can put crg./config. Okay, and now I can run my my node, and I can see some logs here. And in the next video, we will see how to create new smart contracts. In the first video, we will see how how to develop a JavaScript smart contract and deploy it in the blockchain. And we will see an example. We will use this node to run our JavaScript smart contract. And in a second video, we will see how to develop a Python smart contract.